In this video clip, we learn how to model nonlinear relationships in regression. The relationship between the dependent and independent variables may be nonlinear. We can use scatter plot to check for nonlinear relationships. We consider a quadratic model as follows. Here, in the population, we assume there is a quadratic relationship where yi equals beta 0 plus beta 1 times x1i plus beta 2 times x1i squared plus epsilon, a random error term. Here, the second independent variable is the square of the first variable. So here we have the model. Quadratic regression model, we assume the y variable and the x variable has a quadratic relationship as follows. If we use a linear regression model, then the linear fit does not give random residuals. When we use a quadratic regression model, then nonlinear fit gives random residuals. So there are 4 different curves regarding quadratic relationship depending on the signs of beta 1 and beta 2. For example, if we have beta 1 negative, then y decreases with x. Further, if we have beta 2 positive, then we have a slope increasing. Similarly, we have the other 3 patterns regarding quadratic relationship. We try to find a regression equation as follows, where we estimate B0, B1, and B2. Regarding the overall relationship, we test the null hypothesis beta 1 equals beta 2 equals 0. That is, no overall relationship between x and y. In H1, the alternative hypothesis, we have beta 1 and or beta 2 non-zero. So there is a relationship between x and y. To test the overall relationship, we use an F-test. The F-test statistic equals M minus R over M minus E. Okay, to test the quadratic effect, we compare quadratic regression equation with the linear regression equation. Here we test null hypothesis beta 2 0 and alternative hypothesis beta 2 non-zero. So here we can use a t-test where this t statistic follows a t-distribution with n minus 3 degrees of freedom, where n is the sample size. Here is an example. We have purity and filter time. Here purity increases as filter time increases. So here if we run a simple linear regression, we obtain the following equation, where we have the t-test p-value very close to 0. So this number is 2.078 times 10 to the power of negative 10. Similarly, we have an F-test statistic and the same p-value as the t-test. because here we only have one independent variable. So here, t statistic, f statistic, and adjusted R-squared are all high, but the residuals are not random. If we use a quadratic regression model, we have the following equation. Here we have the p-value for the t-test of the squared term slope. It's close to 0. Okay, so that means the quadratic term is significant and improves the model. Also, we see the adjusted R-squared is greater than the linear regression model here. Also, we see the residuals are random.